Section 2.4, Newton's third law of motion. So in the last section, we talked about the idea of force pairs and the idea that if you push on something, it pushes back on you, right? So every time there's some force interaction, it always occurs between two objects. Newton's third law builds on that idea, and it's one of the really, really important ones, but it's also probably one you've heard before in one way or another. It's probably the most famous one. So Newton's third law basically just says whenever one object exerts a force on a second object, the second object exerts a force of an equal and opposite magnitude on the first object. So if you push on the wall with a force of 10 newtons, the wall pushes on you with a force of 10 newtons in the opposite direction. If you push on a ball with a force of 50 newtons, the ball pushes back on you with a force of 50 newtons. Okay, this is also known as the action-reaction law, and the way you've likely heard it before is for every action there's an equal and opposite reaction. That comes almost directly from Newton's third law of motion. It simplifies it a bit, okay, but you could just easily say for every force there's an equal and opposite force. And those forces are shared between the two interacting objects. Now, that is not to say that those two interacting objects are going to experience those forces in the same way. And we're going to talk about that more further as we go along. Here are just a couple examples from the textbook of action-reaction pairs. Right, so your tires in your car, they push on the road, and in reaction to that, the road pushes the tire, moves your car forward. Okay. Rockets expel fuel. Right? They push gas out, and so the gas coming out pushes the rocket forward. And if you pull on a spring, then the spring pulls on the man. And if Earth pulls on a ball to the ground, then the ball pulls up on the Earth. Now, the last example is an extreme difference between two objects, right? So you have a small ball on the surface of the Earth, right? So the Earth is a very large object, and the ball is very small. The gravitational force that the ball experiences is the same as the force that the ball applies to the Earth. So when a ball is falling to the ground, while the Earth is pulling it down, the ball is pulling it up with the same amount of force. Okay? Same is true for you. When you stand on the Earth, you push down on the Earth, and the Earth pushes up on you. But when you have objects that have extremely different masses, then the outcomes for those particular objects, in the case of the force, can be very different. And so, if you are, for example, if you drop a ball, as we've been talking about, the ball gets pulled to the ground. It moves, right? It experiences that force and it moves. The Earth experiences the same force, but it doesn't move. And it doesn't move because the Earth is much more massive. And things that have more mass have more inertia. And more inertia means it's harder to move them. Another example is a cannon firing a cannonball. And you've likely seen this in movies. And if you haven't, The Patriot with Mel Gibson. A bunch of good scenes of showing how cannonballs fire. But when you fire a cannon, the smaller cannonball goes forward, and the cannon itself gets pushed backwards. The cannon pushes on the cannonball and shoots it forward, and the cannon goes backwards. Not nearly as much, okay? But this is why they would build cannons on wheels. When they would fire, the wheels would allow it to roll back a little bit. You see that clearly in the movie, or in any movie where they show cannons, or in any place where they show cannons. You can see it watch old football games, or if there's football season this year. So we use the same concept to essentially get a rocket into space. The rocket expels the fuel, it pushes out of the rocket, and as it's doing that, the rocket is pushed upwards. The rocket, as it burns fuel, becomes lighter, it's easier to push, and so it gets faster and faster as it goes upwards. Now, the next question inherently is if the forces are equal and opposite, why don't they just cancel out? Why are there any forces at all? And in the case of a closed system where we're only talking about one particular situation, closed system where all the forces are internal to that system, there are no external forces, then all the forces do cancel. And so for example, if you have a baseball just sitting at rest on a table, there are tons of molecular forces inside that baseball, and there are molecules moving and all these other things. But because all of those forces are contained within the baseball, the sum of those forces essentially are zero and the baseball doesn't move. Same is true for pretty much all objects at rest. There's some amount of action going on with the particles, but all those forces essentially cancel out. If you want a system, an object, something to accelerate, something to change its velocity, then you have to have some kind of outside force. You apply a force to that baseball to cause it to move. If you never touch the baseball, and no one ever touches the baseball will never move. Okay? Much in the same way, Newton's third law also allows for human flight. It allows planes to stay in the air because planes push down on the air as they go up. Okay? Now in chapter 5, we're going to talk a bit about how planes fly, particularly how the air behaves around a plane wing. But I'm going to go ahead and tell you now that it's a simplification of what's actually occurring. And that simplification leaves out the idea that the plane itself is literally pushing on the air to lift it up. Go back to our last little exercise where you have your hand out the window, right? So if you have it flat, or if you have it, perpendicular to the ground, so that, either parallel or perpendicular. And you'll notice that as you go from one to the other, if your hand's outside the window, when you reach an angle about 10, 20, 30 degrees, you're going to see your hand catches air and it'll go up, right? It's because your hand is angled in such a way that as the air hits it, it bounces off and pushes down, and it lifts the plane up. And so in chapter 5, we're going to talk about one piece of how airplanes get off the ground. This is the second piece, and I'll discuss it further then.